So you need to know that enzymes are proteins. You should also know by now that proteins are made up of amino acids. They must join together in the correct sequence. If they don't, we're going to get a change in that enzyme and it won't work anymore. So how do they work? These enzymes attach to a molecule called the substrate, the thing that's going to react. That active site and the substrate fit together like a lock and a key. You know that a key will only open or fit in one lock. It's exactly the same with your enzyme and your substrate. They've got to match, the shape's got to match. If they don't, that enzyme won't work anymore. Okay, so we call that our lock and key hypothesis. So you've got your enzyme at the bottom there. The yellow bits are your substrate, so they come together, they form that complex. What do you notice about the enzyme at the end? Look really carefully, look at the enzyme. Does it look any different to how it started? No, it looks exactly the same. So if you think back to those first key 3 points that you wrote down, an enzyme doesn't get used up. So I could take that enzyme out now, put it into a different reaction, and it would work all over again. Things that can affect enzymes. pH. Some enzymes are really, really good at working in acidic conditions. Some aren't. So that pH is really important for them to work. Temperature. Enzymes work best at around 37. Why is that? What do you know about 37 degrees? Body temperature. Okay. Too hot and they'll become denatured. That means their shape changes. Too cold, they're not going to work quickly enough, so they're not going to be useful for us anymore. Substrate concentration. If we've got plenty of substrate, our reaction's going to happen quickly, but only until all of those enzyme active sites have been used. Okay. Anybody describe the trend in that graph? So think about what describe means. You don't have to tell me why, you just have to tell me what is going on in that graph. So you've got rate of enzyme activity and you've got temperature. Yeah, so as the temperature increases, the rate increases. So you've started off, now finish off that graph. Doesn't have to be you, Megan. When?
At optimum temperature.
Optimum temperature is when it's happening fastest. It decreases when the temperature... Look. Okay, so at low temperatures, our enzyme activity is low. As we get warmer, our enzyme activity rises until it gets to its optimum, its best. As that temperature continues to rise, our rate will come down. Right. Okay. pH. Same graph. This time you've got pH along the x-axis instead. So describe what's happening this time. What happens at low pHs? So pH 1 to 5, should we say? What's our rate of enzyme action like? Yeah?
Increased.
Increasing, good. When we get to about pH 7, pH 7,
Stays the same.
it's at its optimum, its best. From 7 to 14, decreasing. Okay. What I would like you to do is fill out your little question sheet.